Hi, I am Gladys. Welcome to my channel. In this video, let's see what is Zener diode. Zener diode is specially designed, heavily doped diode which operates in both forward and reverse bias condition when enough voltage is applied. The PN junction diode does not conduct when it is reverse biased. Normally in PN junction diode, the breakdown voltage is so high. So when it is reverse biased, it damages the diode permanently. But Zener diode is designed in such a way that breakdown voltage is less. Zener diode is also called as breakdown diode. Diodes are manufactured with different Zener voltages. It is used as a voltage regulator. This is the symbol of Zener diode. The symbol of Zener diode is same like normal diode, but the difference is the edges of the bar on both the sides is bent upward and downward. This is the construction of Zener diode. There are many methods of manufacturing Zener diode. This method is called diffused method. In this method, the N substrate and P substrate are diffused and the metallic layers are used to connect the cathode and anode terminals. The other methods are passivated structure and alloy diffused structure. Next, we'll see about the working of Zener diode. When Zener diode is forward biased, that is, when P-type is connected to positive terminal and N-type is connected to the negative terminal, it acts same like the PN junction diode. The value of the potential barrier of the depletion region for silicon is 0.7 volt and for germanium is 0.3 volt. So when the applied external voltage is more than the potential barrier value, the free electrons and holes gets the extra energy to cross the depletion region, and thus the depletion region decreases in size and the current starts to flow. So during the reverse bias condition, that is when Zener diode is reverse bias, that is when N-type is connected to the positive terminal and P-type to the negative terminal, only leakage current flows, but after reaching Zener voltage, current starts to flow. The breakdown voltage of the Zener diode when reverse biased is called Zener voltage. In the reverse bias condition, when the voltage is increased, breakdown happens in the depletion region and current starts to flow. Next, we'll see about the Zener breakdown. Zener breakdown is sharper than the avalanche breakdown. Since Zener diode is heavily doped, the impurities are so high, so the depletion layer is very thin. So even for a small reverse voltage, they start conducting. When the reverse biased voltage continues to increase, the electrons in the depletion region breaks from the covalent bond and thus the depletion region becomes conductive. This is called Zener breakdown, and the voltage at which Zener breakdown happens is called Zener voltage. Zener breakdown happens at lower voltage than avalanche breakdown. Next, we'll see about avalanche breakdown. When it is reverse biased, the depletion layer increases and reverse saturation current due to the minority carriers will be flowing constantly. When the voltage is increased in the reverse bias condition, the minority carriers gains enough kinetic energy and collide with the immobile ions in the depletion region. This results in more free electrons. These free electrons collide with each other, forming more free electrons. So this leads to huge free electrons in the depletion region and the whole diode starts conducting. This is the avalanche breakdown, and this is the avalanche breakdown, and this is the Zener breakdown. We can see Zener breakdown is sharper than the avalanche breakdown, and the voltage where the Zener breakdown happens is the breakdown voltage. This is the VI characteristics of Zener diode. When the diode is forward biased, when the external applied voltage is increased, and when it crosses the value of potential barrier, the current increases steadily, as we see in the figure. When the diode is reverse biased, when the applied voltage is increased, breakdown happens in the depletion region and the current starts to flow. When the reverse biased voltage continues to increase, the electrons in the depletion region breaks from the covalent bond, and thus the depletion region becomes conductive. This is called Zener breakdown, and the voltage at which Zener breakdown happens is called Zener voltage. The advantages are small size and less expensive, good control over the flowing current, it can handle high voltage. Disadvantages are electricity is wasted during the process since it cancels voltage by applying larger voltages in the reverse direction. Poor efficiency, internal impedance is high, it cannot be used for large load current. The applications are used as voltage regulator, used as meter protector, used in clipping circuits. So thank you for watching. If you like the video, please like, share and subscribe.